Good morning, students. I am myself C. Radhakrishnan, working as an assistant professor in Computer Science and Engineering Department, Kongunadu College of Engineering and Technology. Today, we discuss about RSA algorithm, public key cryptography concepts. So already we studied in first unit and second units are basic introduction about the cryptography, what are the terminologies are involved, how the encryption process will be carried out, how the decryption process are implemented, and as well as generally cryptographic concepts. Now, public key cryptographic concept we are discussed now. In this time, public key cryptographic means what we decide that. So public key cryptography, it will be provide the authentication and secrecy of our message. So now in this topic, we are discuss the public key cryptography concepts. So in this case, we are implemented with two different keys, encrypted with private key and decryption process will be carried out in public key. So till now we studied from first unit and second unit, both encryption and decryption, both are all implemented with the same secret key. That means shared secret key. In the public key cryptographic concept, we are implemented with encryption process with the help of one key, decryption process is another one key. That's why we call it as public key cryptographic methodology. So here original message will be converted into ciphertext, so that in this original message, now I pointed as in some highlighting. So marking. So for rectal marking, I will intimate this is our source part. This source part, your original message will be in X, which is implemented into encryption algorithm. This encryption algorithm will take the input as private key of the user. Private key of the user. So user's private key, with the help of user's private key, it will be implemented for encryption algorithm. It will be converted into some information of encrypted information. It will be converted. This private key encryption you have to perform. And similarly, this particular encryption algorithm will also produce the Z value that will be implemented in the decryption process. In the destination side, with the help of the public key algorithm, so first one, public key cryptography encrypted with sender's private key and as well as encrypted with receiver's public key. So automatically will convert it as a ciphertext. In this receiver end, the decryption process will be carried out with the help of a receiver private key first. After that, the decryption process, again one more decryption process will be carried out with the public key of the sender. So finally you will get the message digest of your original message. Now, so this encryption process will be in terms of two locations, private key of the user sender and public key of the receiver is converted into ciphertext. In the receiver end, first the decryption process will be carried out with the receiver private key, and the decryption again will be implemented for sender public key. You will get the result for final target code. Final target instruction will be we will get the final target value, that is final original message. So this particular encryption algorithm, encryption brief applications of public key cryptography concepts are encryption, decryption means we have to implement it. So the sender encrypt the message with the receptions of public key concepts. On digital signature, the sender signs the message with the private key. So automatically it will be digital signature concept will be implemented. And key exchange, two sides cooperated to exchange the session key, that means secret key will be exchanged together. So these are some basic informations about applications of public key cryptography system. Now we discuss with the RSA algorithm. So abbreviations of RSA is nothing but reversed Samir Edelman scheme. It is developed in 1977 by MIT by Ron Rivest, Adin Seymour, and Lynn Edelman. So most widely used general purpose approach to the public key encryption concepts. In a cipher is a cipher in which the plain text and the cipher text are integers between 0 to n minus 1 for some n values. The size of the n value should be its maximum of 1024 bits or 309 decimal digits. So this is our initial configuration or initial assessments of RSA algorithm first defined. So RSA algorithm makes use of the expression with exponentials. Plain text is encrypted in blocks with each block having a binary value less than some number of n value. And encryption and decryptions are of the following form. For some plain text block M and cipher text block C. So ciphertext will be calculated m power e modulus n, and similarly the original message will be again retrieved ciphertext power d modulus n is equal to m power e whole power d mod n is equal to m power ed modulus of n. Both sender and receiver must know the values of n is a major important point, and the sender know the value of e and only the receiver know the value of d. So E is our private key and D is our public key. The public key encryption algorithm uses the public key as BU is equal to EN and private key is nothing but DN. This is our initial steps for following the RSA algorithm. The algorithm requirements. What are the requirements of this algorithm? For this algorithm be satisfactory for the public key cryptography concepts, so following requirement must to be met. First one, it is possible to find the value of EDN such that m power E into D mod n is equal to m for all m less than n. This everything will be the modulus arithmetic operation. The modulus arithmetic applications, everything will be involved in this public key cryptographic concepts. It is relatively easy to calculate m power E mod n and C power D mod n for all the values of m less than n. And it is infeasible to determine D given E and n. That will be discussed. So this is our algorithm steps. So this just I will expand the particular graph. Okay. So key generation from Alice and Bob, they are considered. So Alice is our center, Bob is our destination. So select P and Q value. So both are all prime number and both are all not equal. That is our initial constraint. So select P and Q value. Both P and Q are prime numbers and both are all not equal. And to calculate the n value, so the n value is nothing but P into Q. And to calculate the Tartian function of n, Tartian of n is equal to P minus 1 into Q minus 1. And select integer E value. So E value calculation is nothing but GCD of the greatest common divisor of Tartian function n, comma E value must be 1, and E value is nothing but 1 to Tartian function. So E value will be taken in the form of it will be greater than or equal to 1 and less than or equal to Tartian function n. And the D value will be calculated. So D value is nothing but calculated. D is equal to E inverse 1 modulus of Tartian function n. That is our calculation of the D value. And you have to perform the public key from this E value, D value, n value. We define that the public key PU is equal to E comma n and private key PR is equal to D comma n. So encryption at Bob's side, encryption by Bob with Alice public key. So plain text will be M. Ciphertext M is ciphertext C equal to M power E mod n. Here E is nothing but our public key of the BOP. So public key of the receiver end. And decryption process will be performed. The ciphertext will be the input, that will be C, that is a ciphertext. Your original message M will be retrieved is equal to C power D mod N. Here D is nothing but private key of the receiver, private key of the sender, so that D comma N. So this is the way our input algorithm will be implemented. So this is our algorithm steps. Now we have to perform the RSA algorithm. Your plain text will be 88 and encryption process will be carried out. M power E value, public key value will be 7, N value will be 187. The ciphertext will be 11. The ciphertext will be implemented into decryption process. The D value, private key of the sender, will be 23 and N value will be 187. Your ciphertext 88 will be generated. This is our example problem, simple methodology. How it will be work is nothing but here presented. So general approach or example. So general approach, so our plain text block ciphers into P1, P2, P3, the ciphertext value will be calculated. From the ciphertext, we have to perform recovered images. Original message, public key will be implemented. Public key, from the public key E comma N, the ciphertext will be calculated. From the ciphertext, the private key will be calculated. From the private key with the recovered plain decimal text will be calculation. Finally, you have to receiver and it will be generated. So this is our process. So what is the security of the RSA algorithm? So first, in our RSA algorithm, we focusing on totally are 4 major points. P and Q value will be calculated. Both are all prime not equal. And N value will be calculated for a P into Q. And Tardian function will be calculated in terms of P minus 1 into Q minus 1. And the E value will be given or identified. D value must to be calculated. After that, you identify the public key and private key concept. After that, you perform the encryption process and decryption process. The corresponding equation, we can substitute the corresponding value and perform the modular arithmetic modulus operation. Finally, we will get the original plain text. Plain text will be decrypted means, sorry, so plain text will be encrypted means ciphertext will be generated. Ciphertext will be replaced, converted into plain text. Finally, we will get the answer for original message. That's why we define that RSA is a public key cryptographic methods. Now, another important point of why mostly we are using RSA algorithm. 5 possible approaches to attacking RSA. RSA, security of RSA means first one, brute force attack involves trying all possible private keys. So brute force attack means there is a possibility for it trying to approach all the private keys. So automatically we called as, because the RSA algorithm will be implemented, private key of the center, public key of the receiver will be encrypted, private key of the sender will be decrypted. So automatically the private key encryption with the public key, decrypt with private key. So automatically that's not possible to attacking the original message by using brute force. Next one, mathematical attacks. There are several approaches, all the equivalent in effort to factoring the product in 2 primes. So here we are implemented for 2 prime numbers multiplication process. From the prime number only we are implementing. So all the mathematical computations will not be executed. Automatically we will get the full security. And timing attack, this depends upon the running time of the decryption algorithm. So it's time for decryption algorithm. At the time of decryption algorithm, based on the timing, there is a possibilities of attack. Also, it's not possible in this RSA, so that it will be the RSA having the fullest security. Hardware fault based attack is possible or not possible, and chosen ciphertext also is implemented. So this type of attack explicit properties of the RSA algorithm. So factoring problem is nothing but is calculated for 2 prime numbers. 2 prime numbers Tardian function will be calculated. From the Tardian function, D value will be calculated equal to E inverse 1 modulus Tardian function of N. So dot in of n directly without first determine. So dot in function is not directly computed because without knowing the two prime number, there is no possibility to identifying the dot in function. So factoring problem is purely depends upon prime numbers. Without knowing the prime numbers, we are not in position to derive whatever remaining elements of the RSA elements. So factoring is the major impact role in the RSA algorithm. So timing attack. So timing attack also is another important technique. So cryptography consultant demonstrate the snooper can determine the private key, keeping track of how long a computer takes in a deciphering message, are applicable not just a RSA but together public key cryptographic system. So alarming of two reasons. It comes from completely unexpected directions, and it's ciphertext only attack. So next, similarly, public key cryptographic answer to for Delphi element exchange, it will be discussed in the next video. So thank you for students. So this today till now we discuss about the today's session for public key cryptographic concept of implementing RSA algorithm and the attacks and properties. Thank you.